Welcome back. In this video, we'll get started with some basic Docker commands. As we saw in the last video, we'll be pulling an image from DockerHub to our local machine, then run a container instance from that image. Before we do that though, I'll show you in Docker Desktop by clicking the Containers tab that I currently have no containers on my local computer, nor do I have any images. Now, going forward, I won't be using Docker Desktop GUI to interact with Docker. I'll be using the terminal and executing Docker commands. So if I want to see which Docker images I currently have on my computer, I could execute the command docker image ls. And this will show me I have no current images, just like we saw in the Docker Desktop GUI. I can do the same to check the containers on my machine with docker container ls. And again, we see we have no containers. So what we would like to do is get a local copy of this hello world image from DockerHub to our local machine. And we can see the way to do that is to execute this command docker pull hello world, where hello world is the name of the image that we want to pull from DockerHub. So I'll copy this, go back to my terminal, paste it in, and execute. And we can see that it's pulled the latest copy of hello world from DockerHub. Now, if I do a docker image ls, we see we have an image on our machine. But if I do a docker container ls, we see we still don't have any containers. So let's build and run a container from this image. And I'll do that by executing the command docker run hello world, where hello world is the name of the image that I want to use to spin up this container. So I'll go ahead and hit enter. And we see that we were successful in creating and executing the container from the hello world image. Now, if I execute a docker container ls command, well, we don't see any containers. And that is a little troubling because we just said that we pulled an image from DockerHub and then we used a docker run command to build a container and execute it, but why aren't we seeing it? Well, that's because the container executed and then terminated. So if you want to see containers on your computer, regardless of the state they're in, either running or terminated, you can execute the docker container ls -a command. And now we see the instance of our hello world container, which terminated 57 seconds ago. Now, let's say we no longer have a use for the container because it's terminated and we don't want it taking up space on our machine. So we'd like to get rid of it. And the same thing with the image. Okay, we played around with the hello world application. It was great for this tutorial, but we don't really need it. So let's try and delete that image. And we'll do that using a docker RMI for remove image. And then we'll give it the ID of the image. Hit enter. And we get an error saying that Docker's unable to delete this image because it's being used by a container. Well, it's being used by a stop container, but it's still being referenced by a container. So in order to delete an image, we first have to delete the container or containers that were built from the image. So we can execute a docker container rm command passing the container ID. And if I spell container right, it may work. And we get the response back with our container ID. Now, if we do a docker container ls -a, we see we no longer have that terminated container. And of course, we don't have any running containers either. Now, with the container deleted, we can issue that docker RMI command, passing it the ID of the image to delete the image. So we do that, and then run a docker image ls, and we see we no longer have any images on our computer. All right, so now we know how to pull an image from DockerHub. We can create and run a container instance from the image, and we can clean up after we're done. But that hello world container wasn't very useful. Sure, we were able to run it and it did something for us, but it terminated right away. And in fact, that's really what containers are supposed to do. They're supposed to run the app deployed in the container, then when the app completes running, the container terminates. But what if we want to run an app that's longer running, like spinning up an operating system and interacting with it? Well, to do that, we could start by pulling, let's say, an Ubuntu image from DockerHub. And the image has been pulled. And we could see it if we execute a docker image ls. Now, notice when we executed that pull command, it took a few seconds to download that image. And that's because we didn't have the image on our local machine. Now, if I go ahead and run that command again, it was actually faster this time because the image was already there. The first time, it pulled the latest Ubuntu image from DockerHub, and we saw that the pull was complete. The second time, it pulls the Ubuntu image again, but it doesn't have to pull it from DockerHub because the image is already on our local machine. So as long as we're using the same image to spin up multiple containers, we only have to pull it once. If we want a different tagged version of the image, we can re-pull it. But once that image is on our machine, we could just utilize it without having to pull it from DockerHub. Now, let's run a container from that image using the docker container run command. And before I hit enter, I'll add some flags. I'll start with the -i flag to tell Docker that we want to make this instance of the container interactive. Then I'll add a T, which will give us a terminal that we can use to execute commands inside of the container. Then I'll give the container a descriptive name. And now I need to specify the ID of the image that we want to use to spin up the container. And as a shortcut, we really only need to provide the first few characters in the image ID, just enough to distinguish it from the IDs of any other containers that we may have on our system. Now, with this command fully built, I could go ahead and hit enter, and it spins up an instance of a Docker container for us. And we're actually inside of the container right now, running as root. So because I specified the -it flags when we ran the container, I now have an interactive terminal that I could use to execute commands against the Ubuntu operating system. So if I execute cat/etc/issue and hit enter, we'll see the version of Ubuntu that we're running inside of the container. And I can quit the container by typing exit. And if we do a docker container ls -a, we see our container named my Ubuntu container, which is exited 14 seconds ago. Now, if I try to spin up another instance of the container and I use the same name, I'll get an error saying that there's a conflict with a container already using the name my Ubuntu container. So if I no longer need the container that's terminated, I can delete it, or I could just give this instance of the container a new name. So let's just go ahead and delete the terminated container. Now, previously we saw that we could remove a container by passing the container ID. And again, we only need to give enough characters to distinguish it from any other container IDs that we may have on our machine. But we could also pass the container name if we know it. And it returned the name of the container. So if we do a docker container ls -a, we'll see that we no longer have any containers running or terminated on our machine. Now, we've created a container based on the Ubuntu image. And by default, when we pull an image, if we just specify the image name, we'll get the latest version. If we want a specific version of an image, say a different version of Ubuntu, we would have to specify a tag. So because we didn't specify a tag when we did our Docker pull, we got the latest version. If we fully qualified the image with the latest tag, this is what it would look like. And if I go ahead and hit enter, it'll check to see which version of the image we have locally. And because we already have the latest, because here's the tag, it doesn't pull it down. It already identifies it as being on our system. Now, let's say we want to run a container with a different version of the Ubuntu OS. Well, we'll have to go to DockerHub and to the Ubuntu page in DockerHub, and then we could see the supported tags for this image. Now, let's say that we want to run a version of Bionic. Well, we could use any of these tags when we do our pull. So let's take the 1804 tag and go back to the command prompt and pull that version. So we specify the tag, hit enter, and it goes out and downloads the image because we didn't have it on our machine. And if we do a Docker image ls, now we see we have 2 versions of Ubuntu with different tags. In the next video, we'll pull down an image for a web server from DockerHub, expose a port, and access it from our local machine. I hope you're excited to do that, and I hope to see you there.